When you use a really powerful AI, it feels like magic, right? But behind the scenes, there's this whole complex system at work. So in this explainer, we're going to pull back that curtain and show you the actual blueprint for building pretty much any AI.
So let's say you've got this great idea for an AI app. Maybe it's a simple chatbot, maybe it's something huge that could completely change an industry. So many people are trying to do this right now, but it always kicks off with the same kind of daunting question. Where do you even begin?
Well, the very first thing to get your head around is that you're not just picking an AI model, you're building an AI stack. And that's the mental model we're going to use today. Think of it as a series of layers, each one stacked on top of the last, and each one requires some pretty big decisions. And here they are, the 5 layers of any modern AI system. You've got the application at the very top, then orchestration, data, model, and all the way at the bottom, infrastructure. We're going to build this whole thing from the ground up, starting with that foundation.
Every great building needs a solid foundation. And for AI, that foundation is really built on 2 huge decisions. What is your AI actually going to be, and where is it going to live? So let's start right there.
The absolute bottom layer is the infrastructure. This is the raw horsepower, the physical or virtual hardware, almost always these super powerful GPUs that makes everything else even possible. Now, to make this feel real, let's imagine we're building an AI that helps scientists analyze the latest drug discovery papers. That's a serious job, right? So our choice of infrastructure is totally mission critical.
And you have a major choice to make right out of the gate. Are you going to go on-premise, which means buying, housing, and managing your own powerful servers? Or do you use the cloud, renting all that power from a provider like Amazon, Google, or Microsoft, which lets you scale up or down in an instant?
Of course, there is a third option, and it's a lot more accessible. For smaller, more specialized models, you might actually be able to run everything you need right on your own laptop. It's perfect for just experimenting. But for our big, ambitious drug discovery project, we're going to need a lot more firepower than that.
Okay, so we've figured out where our AI is going to run. Now we get to move up one layer to the really fun part, choosing the model itself.
Now, just look at the choices here. Every single row is a critical decision. For type, are you going to go with an open source model that you can tweak yourself, or a proprietary one from a big company like OpenAI? For size, do you need a massive large language model, an LLM, or can a smaller, more efficient model get the job done? And for function, do you want a generalist that can kind of do anything, or a real specialist? For our drug discovery project, we'd almost for sure lean towards a model that's specialized in scientific research, just to get the best possible results. All right, so we've got our hardware, we've picked a model, but here's the thing. A powerful model is only as good as the knowledge it has. So let's move up to the data layer and figure out how we keep our AI on the cutting edge.
And this is the fundamental problem you run into. Most AI models, they have a knowledge cutoff date. They literally don't know anything that's happened since they were trained. For our drug discovery AI, that's useless if it can't analyze research papers that were published, this week. So how in the world do we feed it brand new information?
The solution is this really powerful technique called retrieval augmented generation, or just RAG for short. The best way to think of it is like a personal research assistant for your AI. So when the AI gets a question, the RAG system first goes out and finds the most relevant, up-to-date information from an outside source, like our private database of new scientific papers. Then it hands that fresh info to the AI so it can give a much, much smarter answer. This just shows you how it works in action. It's actually pretty simple. The user asks a question, the system goes and retrieves the most relevant new data, probably from a specialized vector database. Then that new data gets packed right into the prompt, giving the AI all this fresh context. And then finally, the AI generates an answer based on this new, up-to-date knowledge. It's a simple idea, but it's an incredibly effective way to keep your AI current.
Okay, so our AI now has a powerful model, and it's got access to fresh knowledge. But how does it handle really complex, multi-step problems? And how does a person actually use it? For that, we've got to climb to the top 2 layers of the stack.
See, a simple back-and-forth Q&A just isn't going to cut it for our drug discovery tool. A researcher might ask it to do something like summarize the top 5 recent papers on molecule X, compare their methodologies, and tell me if you see any contradictions. That requires a real strategy.
And that is the job of the orchestration layer. It basically acts like a project manager for the AI. It takes that big, messy request and it breaks it down. First, it thinks, creating a step-by-step plan. Then it executes that plan,
maybe calling on other tools or searching a bunch of different databases. And finally, and this is where it gets really advanced, some systems can even review their own work, critiquing and improving the answer before they ever show it to you. So we've built the entire engine. Now we need the cockpit. We need the steering wheel. The final layer, right at the very top of the stack, is everything the user sees and touches and interacts with. That's the application.
So here's the thing. A great application is so much more than just a chat box. The interface might need to understand really complex scientific data, not just text. It has to integrate with the other software our scientists are already using. And for trust and usability, it absolutely needs features like being able to revise answers and, maybe most importantly, provide precise citations for where it got its information.
So there you have it. We've built our entire AI stack, from the silicon in the infrastructure layer all the way up to the pixels on the screen in the application layer. But why is thinking about it in these layers so important?
It's because every single choice you make, from picking the cloud over on-prem to how you design that chat interface, it all has a direct, massive impact on the final product. Nothing happens in a vacuum.
Ultimately, every decision in the AI stack boils down to a balance between these four things: quality, speed, cost, and safety. And here's the key takeaway. You can't always have it all. These are trade-offs. If you want to improve quality with a bigger model, well, that's going to mean a higher cost and probably slower speed. If you want to optimize for safety, that might require extra steps that slow everything down. Each layer of the stack is like a lever you can pull to find the perfect balance for what you're trying to do.
Once you understand the AI stack, it stops being this mysterious black box, and it becomes a practical blueprint. It shows you the choices you can make and the trade-offs that are involved in designing a really effective AI. So I guess the only question left is, what are you going to build with it?